Hello and welcome. Thank you all again for attending today's session. My name is Jasmine Shoemaker, and I, along with my colleagues Joe Lee and Lorraine Ojo Ohekwari, founded the UMBC Library's AI and Privacy Symposium. On the heels of the successful AI Privacy and Ethics Symposium of April 2024, we're back with a new iteration. This fall's title is Exploring the Gadgets and Gizmos in Your AI Toolkit. This semester, our speakers will highlight various topics ranging from Google Gemini and its integration into UMBC platforms to the broader legal implications of using generative AI and much more. We were intentional with the selection of our speakers, remaining mindful to include librarians, teaching faculty, and students from diverse backgrounds. Although this platform is not an endorsement of specific AI tools, we wish to create an open forum for attendees to learn and interact with this ever-evolving and impactful topic. Our series would not be possible without the contributions from the following centers, departments, and organizations: the Hackerman Foundation, UMBC's Division of Information Technology, the Center for Social Science Scholarship, the UMBC Center for Artificial Intelligence, the Department of Information Systems, and the Department of Computer Science and Electrical Engineering. Today we welcome Eric Stokin, our final speaker of the series. Dr. Stokin is an associate professor of political science and affiliate of the School of Public Policy at the University of Maryland, Baltimore County. He serves as the director of the Center for Social Science Scholarship and the co-director of the Metropolitan Governance and Management Transitions Lab at the Paul H. O'Neill School of Public and Environmental Affairs at Indiana University, Bloomington. His research explores local government decision-making and its impacts on social equity. He regularly uses computational social science techniques to examine how local governments make decisions regarding their economic development, community development, and sustainability policy priorities, and leverages large language models. You can learn more about his research at www.ericjstokin.com. Dr. Stokin's presentation today is titled Advanced Opportunities with AI and Large Language Models, Examples from the Social Sciences. We welcome questions in the chat throughout. Feel free to send a private message to myself or one of my two colleagues, and we'll be sure to ask them at the end of the presentation. Without further ado, I'll turn it over to our speaker.
Great. Thank you so much for having me today. I just noticed one of the PhD candidates from IU Bloomington's here, so thanks for joining from IU as well. I'm really thrilled to be giving this presentation, and I'll start by seeing if I can actually get the presentation shared. So let me see. Let's go into slideshow mode. Can everyone see that okay?
Yes.
All right, great. Well, thank you for that very nice introduction, and thank you to the library and Jasmine and Joe and Lorraine for hosting me today. I appreciate the introduction. I'm going to talk a little bit about opportunities that exist for using AI generally, but also large language models in the context of the social sciences, along with a number of collaborators. I've been using AI tools for probably the better part of 7 or 8 years with applications to various social science research questions. So my hope for this talk is that those of you who come from the social sciences will get a better sense of how we can leverage these kinds of tools and techniques to improve our research and our scholarly engagement. And those who might not be from the social sciences can see how we can leverage those tools. So if you come from data science or computer science or natural sciences, you can understand the kinds of questions that we grapple with and where there might be ways to engage with us. So again, thank you for being here, and thank you for sharing what department you're from and what your role is. It's really helpful. I'll just make a quick plug for the Center for Social Science Scholarship, where I serve as director. All of our events are absolutely open to those outside of the social sciences, so please feel free to join us. Principally, we focus on trying to support the social sciences in a broad number of ways, as you can see, and I'll just highlight one, which is that we also run workshops, and we have workshops in R, we have workshops on computational social sciences, on data visualization. So we hope you'll consider joining us for those sessions. And we'll be delivering one in December focused on prompt engineering and large language models. So you can learn a little bit more about that particular series here, or just go to the CS3 website. So when I think about data science and computational social science. And again, I come from a traditional social science research background. If you're like me, if you're in political science or public policy or economics, you probably had a lot of exposure, even in your graduate level programs, to data analysis, right? The data is often clean, it's in tabular form. What we spend a lot of time thinking about is how do we appropriately analyze the data? We explore correlations. We might get into regression modeling and more advanced techniques. We probably think a bit less about the entire sort of data science life cycle. So this image comes from the University of California at Berkeley, their School of Information. And what I'm encouraging social science faculty and students and others to think more about is the other way in which data science can help improve our opportunities to answer social science research questions. So we need to be thinking about not just data analysis, but also the capture and curation of data, the processing of those data, maintaining them, how we communicate the results, as well as the analysis process. I wanted to sort of illustrate with an example how I might think about engaging in a traditional research approach from the social sciences. Let's say I'm interested in trying to understand how local governments, or how local government actors might identify in terms of their political ideology. I might start by devising a sampling strategy, determine what kind of local governments am I actually going to survey. I administer those surveys. I include questions, maybe a battery of questions that get at core ideological markers. Then I need to determine the representativeness of the data, right? Certainly not every local government is going to respond. It's often going to be skewed in various ways. How am I handling issues around missingness? Maybe it's that larger governments are more likely to respond to surveys because they have greater capacity. And depending on what my research question is, this might present a real challenge for me. So, how a data scientist or a computational social scientist might think about this is to use a different set of tools to address this very same question. We might get a master list of, say, government websites, and this is certainly not the only way one can approach it. We could use financial reports that maybe have to be made to the U.S. Census Bureau, for example. But from that, we might determine ways within text or even within computer images, and I'll show you this later, ways that we might identify ideology. We create a web-based crawler to scrape the data. We filter out or extract only the relevant information for our purposes, and maybe even use the text within a document or images to discern something like the mayor's ideology. There are challenges to both approaches, and I'm not advocating, I'm not saying we should ditch everything we've been doing. I'm saying that there are ways to supplement and use these in a complementary fashion. So this is, I think opening up different opportunities. There's been a lot of advances that we've seen in natural language processing, how we can actually extract information from textual documents. So if you're a historian, maybe we can use archival records in unique and novel ways. As a social scientist, there are all sorts of planning documents that we can leverage. And my colleague here, Joanne Chung, can certainly speak to this as well. We can get a lot of information about what governments are doing from using those planning documents. We can use tools that are available to understand or discern sound, even tone. As a political scientist, I might care about how politicians structure the language around policies that they're advocating for. And, I can even look at things like tone or facial gestures and imaging to try to understand how that might impact, their electoral advantage or something to that effect. I'll actually give a series of examples of natural language processing and image detection. But these tools can also complement, existing approaches. We can improve how we engage in classification and prediction tasks. So I'll actually demonstrate with an example from Twitter data how I use both an ensemble machine learning model as well as a large language model to try to classify the user or the Twitter user to understand were they, a member of the media or a politician or someone in the general public. We can use traditional tools to do that, but it's harder to do that at scale, right? Um, we can also improve upon, our analyses of complex social phenomena. If you're a social scientist, when we try to model these relationships, we have to understand that there's often nonlinearities, in our data. Like things are not always linear. How do we capture those nonlinearities? A lot of machine learning algorithms are great at detecting nonlinearities, or there's sparsity in data, or there's multi-dimensional moderating effects. Um, you know, Drawing on this toolkit allows us new opportunities to better model the relationships that we're interested in. We can also take advantage of something called ensemble modeling, which allows us to use a range of machine learning algorithms and actually determine or, kind of draw on the strengths of each respective algorithm to identify ways to, better engage in those classification or prediction tasks. I know I'm throwing a lot at you. I'm obviously you're not going to come away as a complete expert in machine learning or large language models, and I myself am still very much engaged in that learning process. But I'm certainly helping or hoping to try to motivate, more of an understanding of what these tools are capable of. Um, and I'll draw on some use cases. Certainly, there's a lot in terms of the literature. I made reference to the fact that political scientists and planners are increasingly using documents like planning documents to understand things like policy learning. We can come to understand how various sustainability techniques are being adopted across local governments by drawing on information and text from those actual plans. Um, we can use Twitter data at scale to understand sentiment, right? Are these tweets positive? Are they negative? And again, I'm gonna, I'm just trying to motivate at this point, and describe some of the tools that are out there. But I'll give you three concrete use cases from my own research. All right. The other thing, when we think about opportunities that exist on the computational social science side, again, often we tend to be using more tabular data. Maybe we've gotten more comfortable with textual analyses, like how do we actually extract information from these planning documents or books or even other publications in using text analysis. But we can also use images, right? This used to be a much more complex task. So for any machine learning experts here, you've probably have engaged if you used images as a form of data, you probably used these kind of complex convolutional neural networks to try to identify elements within images, either image detection or try to, identify features of particular images. And that would really require quite a bit of training in terms of setting up those models. Um, Increasingly we have access to large language models, large reasoning models like Google Gemini, like ChatGPT, that can assist us in this process. And I think the sort of point of entry becomes much easier when using those kinds of tools. And again, I'll describe some examples of that from my own research. Here, I'm just highlighting, some illustrative examples of how images have been used, again, in a political science context, to identify media bias in visual portrayals of presidential candidates. Of course, they have some latitude in selecting what pictures they decide to use. Others, and this is the abstract on the right-hand side, have actually been able to discern, important information from campaign websites. Um, it's not this particular article, but the Anastasopoulos has another article where in nonpartisan elections, he was able to determine the ideology of the nonpartisan candidate based on images portrayed in the background, right? So these are sort of novel use cases, but you can see how it opens up potentially new lines of scholarly inquiry. There's two things that I'll point out on this slide. There's a fairly recent scoping review of how social media images are used across the social sciences. So this is a nice article sort of illustrating, based on their review, where they're seeing images used across the social sciences. Um, I will be providing these slides. In fact, I already have. There are a couple links that I have in them. We're compiling other examples. So if you want additional use cases and access to these resources, they are freely available to you. Um, so you can find other areas where we have been able to identify articles that rely on images from the social sciences. So I want to talk very quickly about three of my own use cases, and I'm using these in the context of the workshop series that we're offering. So if you want to know more about, how to actually engage in some of this, of course, it's hard in the context of a little bit less than an hour to try to get you up to speed on how to actually implement these things. But I hope, if nothing else, you come away knowing like, okay, there are some tools that are available to do this kind of work. And there's also workshop series that are here to help support you. Um, so first, and I'll talk a little bit about a project that is ongoing, in collaboration with the management lab at IU Bloomington. We are trying to see how well we can leverage large language models to identify the actual entities or organizations or governments that are embedded within their climate action plans. There's a number of important reasons that we want to do this from a research standpoint, but you can imagine one of the things that's hard to get at in smaller governments is the level of capacity that they have around sustainability or climate action planning. And it's not always clear who they might be engaged with. And what other organizations and actors might be working with them in the development of these plans. Of course, we can survey them, but there's limitations and drawbacks. I already talked about survey bias as being one of those sources. But also realistically, in the context of a survey, one can only identify so many actors They may not perfectly recall, they may not have the time to get back to you on everything. So this is another mechanism for that. What I'm demonstrating here in this kind of small chunk of code at the top is a large language model. In this case, I relied on ChatGPT to actually examine this planning document. And this is really, there's additional elements that are kind of embedded in this call. This is in R, the R statistical programming language. But there is a package within R called Elmer. That's Ellmer. If you're familiar with R, you might know Tidyverse. It's the same set of developers. They have streamlined the code to make these kinds of calls to large language models. And irrespective of what kind of model you want to call, so if you want to call Google Gemini, if you want to call ChatGPT, if you want to call Grok, if you want to call, you name it, you can do that through the same syntactic structure, this sort of chat, and then there's a dollar sign, extract data. Um, Here I've given it, it's too much to put in the context of this slide, but I've given it the instructions that we created, which was, identify each of the organizations that you find in this planning document, create, a sort of running count of the amount of times you encountered this information, and so on and so forth. So I'm actually embedding the prompting language in that instructions. Then Chicago is basically giving it access to this PDF. There's another R program called PDF Tools that allows you to actually read in a PDF document. And then that is in the R programming language, that is an object that's supplied within this function. And then finally, there's additional information in terms of how I want it extracted and how I want it output. I will caution you, if you use a large language model, I would say it's much better at discerning the entities than it is at generating the counts. Consider that these are still probabilistic models, right? That has implications. I'll say generally as a task, it's not great at doing a running count kind of assignment. But also it will sometimes generate different information across runs. So this is something we have to think about if we're going to use these kinds of tools as social scientists. Maybe it means we run it multiple times and then we have to somehow find a way to aggregate and identify the most likely, count or something like that. There's additional ways we need to think about how we validate these models, and that's going to center on our research question. So, just definitely use these tools with caution. All right. So with that said, I'll turn to another example where I was recently using it to try to detect structural features of a house and trying to identify any elements that might make it dilapidated, right? This can be really important in the context of social science research. Some researchers have used it to identify, actually using automobiles, the kind of class and year of the automobile, using images of that from Google satellite view, whether this neighborhood is gentrified, whether it's disinvested. Here, and there's a lot more code happening to generate the overall issues. But this, again, is using ChatGPT, fairly straightforward framework. I'm happy to supply you the code. And it is, as you can see, I think doing a fairly good job of actually identifying some of the physical features of this home. Um, this image doesn't kind of perfectly correspond. There are multiple images actually happening here. So this is kind of aggregating across a large set of images. But this was one of the use cases, and we ran this in a workshop. What I will say is, again, probabilistic model it gave us a lot of the same information, but it was not perfectly replicating for each of our runs, even using the same prompting language, right? So again, I want to caution you, like these are great tools. Depending on your use case, maybe you can just go in and use it, but you want to think carefully about how you use these tools. Okay, I'll give one more quick use case, or I hope it's quick, and I want to make sure that there's time for questions. So this is from a recent publication with my colleague here at UMBC, Dr. Ian Anson in political science, and Nate Jensen, who's a professor at the University of Texas at Austin. We wanted to try to understand public sentiment um, from tweets, right? So back when it was called Twitter, so this was a long time ago that we did this study. But we were looking at tweets from 2019 or probably like 2017 to 2020 regarding the Amazon headquarters 2.0 decision. Um, uh, if you are not familiar with it, Amazon, the company was looking for a second headquarters. They put out a bid, or they put out a request for proposal, and local governments and state governments bid on this proposal. There are more than 230 local governments that did this. And what we wanted to see was how public sentiment varied based on the whether the bid itself was transparent, whether it was redacted, and to see if that sort of mattered, if that impacted the information context. So that's the backdrop to the study. What was involved is very much an illustration of computational social science, which is, I started this project before Elon Musk took over Twitter. Twitter as a company really made their data very available to researchers. So I was able to scrape like 2 million tweets in the context of about a month. There were about 600,000 users. I was looking at various economic development policies. At the time that I was running this, I was using Python to scrape these data. You can still get social media data. It's in a more limited fashion if you're trying to use X. But there are other sites like Reddit and stuff where researchers are leveraging those data sources. For my project, again, I'm looking at Amazon Headquarters 2.0. I have a lot of other data, so if anyone's ever interested in working with these data, I will say working with Twitter data is not easy. Like, uh, uh, yeah, there's a lot you have to think about, outside of like if you're used to survey data, it's a big adjustment. Like this kind of gives you a sense of what the processing actually looked like. I'm trying to find any references through hashtags and keywords to Amazon HQ2. I could use HQ2 that typically identified it. I have to go in and sort of verify that's the case. I have to remove bots, non-English words for the context of this project and users outside of the US or Canada because of our focus. And then there's a whole set of cleaning and processing tasks that you have to engage in if you're not using a large language model. It's a little bit different. And I'll say that for this project, I tested it out both ways. So I'll talk a little bit about that. And there are some great natural language processing models that exist for doing things like analyzing sentiment. Again, if you're interested in any of this and you want more context, feel free to reach out to me. I know I'm going through this quickly just to kind of give you a sense of how I engage this process. But one of the key tasks that's of interest and important here is actually classifying the user. So I'm going to talk more about that. There are a lot of ways in which I could try to classify the user. I could actually look at the terms that are used in the author description. So like if you're a Twitter user, there you might have through your kind of bio, your author identity, you might have said something about yourself. Maybe you said, I'm an actor training for blah, blah, blah. Okay, well, then I can use that text we have to be really careful that we're not picking up other things, and certainly people are not always forthright about what their actual roles are. They're not all identifying their professions either. So there are some limitations. Um, I'll get information on like the author description, the location, the text. In some cases, if you have an image, we could also discern that and potentially use that information. But then there's the whole process of like trying to clean text. And I always thought this was just, kind of comical, but this is what it's like to deal with Twitter data, US strategic command. Someone probably just like accidentally typed something, and then they're saying apologies or whatever for any confusion that results. It's really hard to work with these data. It's very different than collecting survey data. Um, with that said, kind of a first step in this overall process was to identify, and I'll focus on the user type here, identify a classification scheme where we had inter-rater reliability between members of the research team. So we, achieved a threshold that signified, okay, this scheme works well. We could include members of the media, sort of pro-development actors, the general public, politicians, and it's sort of a limited number of kind of categories that we could discern that were meaningful for this project, right? So we do 100 tweets. We determine the inter-rater reliability here, so a kind of a traditional setup. Um, and then we ask ourselves, okay, great, we have 100, we have 40,000 tweets. How do we scale this up? We can't go through 40,000. It would take a really long time for us to do. We don't have the resources for that. Our initial thought, and this was back in like late 2022, early 2023, is maybe we use Amazon Turkers. These are workers that are basically affiliated with Amazon that take on sort of short tasks, and we could send like ping a number of tweets there, and then people could identify them. But this also wasn't going to be great. We'd have to like think about how we are going to verify accuracy, like how many are they going to do? We have to evaluate these items. Maybe we might have to remove some of the Turker results because there's not fidelity. So it certainly was far from like a perfect mechanism to do this. Um, so what I'll say is one of the research assistants, very nicely for the context of the project, actually reviewed 1,000 of these. So spent a lot of time going through 1,000, and based on our inter-rater reliability scheme. And I did two things. Ultimately, I'll just say for the project, I used like an ensemble machine learning model with a number of different machine learning algorithms to basically determine whether we could appropriately classify the user. And there's a whole process for that, of trying to ensure that you can test this model on sort of a validation sample. So this kind of holdout sample that hasn't been trained on. There's things like k-fold cross validation. So you can find ways using traditional machine learning tasks to do this at scale, right? Um, this is April 2023. I mentioned that because there is not a lot of literature actually using OpenAI. This was like the Da Vinci zero zero 003 model. We're so far past that at this point, and it continues to develop. Um, but I wanted to see how well did it actually do. So what I'll say is at that time, and it would be considerably less expensive today, particularly using this model, it cost about 14 cents for it to classify 100 tweets. I'm showing something different here. We also, try to do stance. But what I'll say is it had a really high accuracy. So there's a validation technique, assessment technique called like a F1 score. It could pretty much accurately classify about 85% of the time compared to the other researchers. So even back then, it performed really well. I did use a fine tuning model, so it was a little bit more complicated. But today, I'm sure doing this at scale again, we could easily leverage these large language models and the efficaciousness, how effective it is, would be even higher. Um, so, the question is, do we stick with our traditional research, processes, or have we gone too far down this rabbit hole, channeling the matrix here? You have the red or the blue pill, or is it purple pill? I think it's purple pill. I'm actually colorblind, truth be told. So, now that you've gone down this rabbit hole, I hope I've gotten you to at least think about some of the utility of a computational social science type approach, as well as some of the limitations that are there. What I'll say is I am absolutely open to questions. I'm providing these slides. So I actually have a lot of resources that I've compiled. This just kind of gives a snapshot. So if you access these slides, you'll see a whole host of useful R functions. And again, if you want to dabble in large language models, this Elmer package does a really nice job of that. So take a look at that. There's a lot there. If you're a Python user, there's information. And then at the end of this, there's just a bunch of papers. So if you want like foundational stuff, like understand the core differences between statistical modeling, kind of traditional research and statistics, and algorithmic modeling. There's some great papers here. Definitely start with the Bremen article. And then there's kind of additional slides and papers that are linked here. If you're interested in computer vision and text analytics, or predicting with machine learning, or trying to engage even in causal inference. And there's a lot more work that's been developed. So I have a link where we're collecting newer information as well. Okay. All right. So I think I got us to the 40 minutes, almost right on. Sorry, I know it's a little fast and furious, but let me open it up to questions.
You did great, Eric. Thank you so much. We did have a question earlier. Can you define what you mean by large language model in the context? That was from Jillian around 12:15. I'm not sure if I recall the context. I think it was around, they asked it around the slide titled Opportunities with Computational Social Science and Data Science. Can you
Hmm.
talk more about that?
Yeah, sure. Again, I do not claim to be sort of an expert on all things data science. With large language models, I think one of the things that is sort of unique um, compared to other natural language processing techniques is that they have identified and relied heavily on what's considered the transformer architecture. And there is sort of this, what I guess what's called like a self-attention mechanism and sort of the last layers of a deep neural network that based on that, it had improved in the capacity to sort of predict that, like the way we might think about it is kind of predict that next word. So it's all probabilistic. So that what that means then is that when we go in to ChatGPT and we ask it the same exact question, we may get different results. We almost certainly, if we're asking a more detailed question where it needs to elaborate, we almost certainly get different word choices that are going to happen because it is probabilistic. So if we just keep querying at the same time, even with the same prompt, we could use the exact same prompt. We're asking it the same thing. We will find that it will give us different information. I don't know if that answers the question, but happy to try to elaborate more.
Okay, we do have another question. I'll just read it off here. You mentioned being careful about how to use these tools overall. I believe it was on the image where you had the kind of dilapidated home with the
Yeah.
car, right? So you mentioned being careful overall. Are there issues with privacy that you see associated with Gen AI tools that utilize image recognition, especially for community neighborhoods, more specifically for marginalized or disenfranchised communities and their vehicles, etc.?
Yeah, yeah, absolutely. So I think there's concerns, at least there's probably more, but there's concerns at two levels. One is that we have to be very careful in terms of the information that we supply to these models. If you are using ChatGPT, if you are using your own personal Google Gemini, understand that the more recent versions of those models may be trained on your information. What I will say, and this is a huge plug for using Google Gemini through UMBC, is that we have an agreement that the information we supply to it will stay with the university, right? Doesn't mean that like only you ever have access to that information, but it does mean that it's contained within the university and that, Google Gemini is not, or Google's not training their next iteration on the information you've supplied. What I'll also say in terms of the kind of overall concern of like image data and with respect to particular communities is that it's not as though these models are perfect and they do have inherent biases, right? Again, part of how they have been trained is based on the information that has been supplied to them, often with inherent biases, with disparaging comments sometimes of particular communities and groups of individuals that live within those communities. And this may very much be reflected in how it's evaluating images, or it's looking at particular cars and making these kinds of associations based on biased information that goes in. So, not only do we need to be careful in thinking about like how do we appropriately use it from a social science standpoint, but I think there always needs to be an understanding and an acknowledgement of many of those biases that are built in. The hard part, I think, for many of us too, is that for most of the foundation models, for most of those big large language models like ChatGPT, like Google Gemini, we don't have access to the full information that they've been trained on. We don't precisely know all the information that has been supplied to these models. And that's a real challenge then, to thinking about how best to use them. There are other large language models that have been built. And I'll say if you go to the Elmer package, you can actually select among like 20 different kinds of models. So it might be worth also exploring those. Some of them may have more transparency in the records and kind of and in their algorithms overall.
Yeah, I appreciate you plugging them. I think privacy has been a key focus in a lot of our talks that we've had over the last month and a half. Real quick, you mentioned some papers at the end of your slides. Did you
Mhm.
get them from the library by any chance?
Oh, interesting. So I did compile a lot of those some time ago. I'm sure I've
Okay.
gotten several of them through the AOK library
Yay.
system. I mean, without a doubt, so um,
Ooh.
it's a wonderful resource.
Use your
Absolutely.
library, folks, wherever you are. Use
Yes.
your library. Okay, I think we have one more question. Feel free, folks, to put your questions in the chat. You can also private message myself, Joe, or Lorraine. We have one more that we have over here. We had a PhD candidate, Jennifer Posada, present a few weeks ago, and her research is also tied to training large language models to better recognize emotion through text.
Mhm. Yeah.
How accurately do you believe these tools can be developed to pick up on the nuances of emotion beyond the literal meaning? And how do you envision this impacting the social sciences overall?
It's interesting, in thinking about trying to respond to a question like this, because what I would say is, if you had asked me in like 2022, it'd be like, oh, it's not going to do that good of a job. And if you asked me in 2024, it'd be like, yeah, I think it's probably going to do a good job. And now I'd say, yeah, I mean, I think we're at this place where, I think here's the thing. there's going to be disagreement among experts, right? Even when I engaged in the Twitter project, like we didn't all have perfect correspondence in how we classified this user, right? So there's always going to be this question of like, oh, does it perfectly predict what the emotion is? That's a really hard thing to do. Obviously, the more information it has, the better. And I mean that in two senses. One in terms of as we iterate through these models and they get trained on more and more information, I think generally speaking, they're going to do a better job. But also, the more context the model has that it's responding to. So, for example, in this question, if it just has my facial features in terms of emotional expression, I mean, I think it's still going to do a good job. If it also simultaneously has like MRI data and brain scans, and it has the facial features and it's been trained on both, it's going to do an even greater job. And I think there's there's a lot of work that's actually happening on that side. I went to this Johns Hopkins event earlier this semester where one of the researchers was talking about how they're currently using these AI tools in large, I mean, now we can kind of call them like multimodal models. Like I'm using the term large language model, but understand that like ChatGPT, Google Gemini, these are really multimodal models, meaning they can handle images, text, images, text, sounds, all that. But they're doing training to try to see if they can actually help people overcome pain by, I don't know if any of you know those Muse 2 devices, like the wearable biofeedback devices. Think that a little more enhanced, where they might be able to work with certain receptors through a wearable device to alleviate pain. So like very long-winded, sort of weird way to get there, but I think the more information it has, the better it's going to be capable to answer questions like that, like something like emotions.
Excellent. Thank you so much. Last call for questions. I know we've got about 8 minutes left. If not, no worries. Last call. Okay.
All right.
Well, thank you all for attending today's session. We've had a lot of fun over the last month and a half. Thank you, Dr. Stoken, for rounding out a well-attended symposium series. To continue supporting future symposia, please reach out to members of this group, myself, Joe, and Lorraine. For recommendations for future speakers, any monetary support you'd like to give. We also greatly appreciate your feedback. So I'm going to drop a feedback form into the chat. We'll also be emailing it out with the recording and slides tomorrow. It has been a pleasure having you all for the last, I don't know, 7 weeks, guys. It's just went really by really quickly. So thank you all for being here. We'll be in touch.
And thanks again for having me today.
Thanks, everyone.